I was out flying my drone this morning to get some footage for an upcoming video when I crashed my drone into the ground and broke the gimbal. Now, I'd like to say that this is an uncommon occurrence, but unfortunately for me, this drone has found its way into the ground, the trees, even a river quite a few times throughout its life. Now, either I'm a terrible drone pilot or a terrible drone builder, or both, but let's take a look at some of the causes of these accidents and see what we can do to mitigate them in the future. Now, to help me diagnose some of these issues, I built a motor test stand. It pivots on two self-aligning bearings and directs the motor's thrust into a strain gauge at the rear. This test stand can measure the thrust per watt of electricity of any motor and propeller combination. If you might like to see a detailed video on how it works, let me know in the comments. When I built the first version of this drone over 10 years ago, I used this airframe and these little motors and motor mounts. Now, the airframe was actually fantastic, but these motor mounts had quite a few different ways of failing. These bullet-style propeller mounts use a collet and tapered sleeve to clamp onto a smooth motor output shaft, which works for a while until either the starting or stopping of the motor undoes the top nut. Or until the whole propeller assembly decides not to be there anymore. One day when I was flying this thing across a river, one of the propellers came clean off the motor shaft and sent it tumbling down into the water, destroying the electronics and the camera that I had on board. So I moved to a new S500 airframe and added an onboard first-person view camera with on-screen telemetry. More on that later, and needed to find better motors and propeller mounts. That's when I came across the iPower 2814 with a proper bolted-on propeller mount and grub screws in the top nut to ensure they would stay tight. And these motors worked, until one of them seized, causing the crash that you saw in the intro. And between me having no spare motors and the supplies being out of stock indefinitely, I unfortunately had to find a different model motor and replace all of them. But I never attempted to fly on these because they all sounded like this. I sent this video to the seller, but apparently they have the motor before ship out, and it can work fine because the magnet in the motor can the noise. Then I asked about the included propeller mounts, which came in a variety of hole sizes and spacings, such that only half of them were usable. They said they would reship me the correct ones, but they never did. So I bought different motors, again. Enter the Feichao MT3508 850kv with no crunching noises when they turn and the right bolt holes in the propeller mount. So that's the end of the woes, right? It's a reliable aircraft now? Well, here's me flying over a fallen tree with a 6-year-old battery that I had never used before. Yeah, old batteries, not a place worth penny pinching. Luckily the weeds provided a gentle landing, but the landing legs and gimbal still broke. Let's look at the telemetry overlay from the pilot's perspective. If you look up the top right corner, you'll see the battery was at 16.6 volts prior to takeoff, and barely 10 seconds into the flight has fallen below 10 volts, and the drone falls. Now, this was a brand new battery that had been sitting on the shelf for 6 years. The charger said it was 100%, but under load it completely failed. Similarly, these old puffy LiPo batteries are a risk not worth taking. When I crashed my drone and broke the gimbal. That's right, don't do it again. And for anyone who hasn't seen this dashing headwear before, these are FPV goggles, which stands for First Person View. They contain video screens that can see through a camera on the front of the drone, and all kinds of helpful data is overlaid in real time. You can see here we have signal strength, GPS satellites received, flight mode, heading, artificial horizon, distance from the launch site, battery voltage, battery current, consumed milliamp hours, altitude, rate of climb, and anything else you might want to add. It's an incredibly powerful resource for a pilot if they decide to look at it. Let's get back to our repair. I don't know if Gorilla Glue is the best solution, but it's what I've got on hand. And I'll order more of these legs if I can still get them, but this should do for now. With all of the broken bits glued back together, it's time for a power on test.
Telemetry recovered.
That's a good start. Let's see if we still have pan control. Yes. And do we still have tilt? Yes. Amazing. Looks like we got away with it, assuming all of that Gorilla Glue holds up, but time will tell. Let's test the motors. Looks like they're all still good as well. We might be able to go for a fly. Now I know I just said not to fly on old worn out batteries, but this will be a quick one, I promise. And we have a safe landing. It's still flying a little rough, but once the new batteries arrive, I'll tune the wobbles out of it. If you see any nice aerial footage in upcoming videos, you'll know that it's still working. Also, did you see that kangaroo? Absolutely scared the pants off me. Thanks for watching, guys. I'll see you in the next one.